Hi, and welcome to this new video about natural language processing, embedding, vector, and so on, in which I'm going to do a more deep dive into the concept of embedding. In the previous video, I demonstrate how we can use a model derived from BERT, taken from Hugging Face, to have the very same result we had with word2vec. So we were able to transform each single word into a vector and try to find the most similar vector to king minus man plus woman, and it's again queen. But now I want to show you that the embeddings in this model are most suitable to work with sentences, with a very simple example that gives you the idea of how this model works. In this example, I have 30 sentences. I have GPT-4 create a sentence for me. All the sentences contains the word tree, but the idea is the very first 10 sentences use tree in a botanic context, so it's tree like a plant. Then I have tree in the context of a computer programming, and finally I have tree in the context of a family tree. So the word is always tree, and all these 30 sentences goes around the word tree, but each one is using tree in a different context. So what I'm gonna demonstrate you is if we are using some transformers, we can have all these sentences clustered together. So all the sentences about tree as a plant are near to other sentences that treat tree as a plant. So these embedding are capturing the context of the sentence. In this code, I'm using the sentence transformer, and then I'm using also visualization utils from OpenAI Plot2D. And this is important because we cannot visualize vector in more than three-dimensional spaces because it becomes complex, and because we are used in two-dimensional spaces, piece of paper, three-dimensional spaces, the reality we are living in, but we are not enabled to perceive more than three dimensions. So there are libraries that analyze long vectors with long dimension, and try to plot them into two dimension, where the concept is I want the vector in two-dimensional representation be near the vector that are near in the nth dimensional space. So if we wanted to show how vector are distance in nth dimensional space, we can use this library to represent in two-dimensional space, and the distance are somewhat maintained, and it gives you the idea of where the vector is in the original space. As you can see, I've chosen one model, but I have commented out some other model you can find on Hugging Face. There are tons of models in Hugging Face and in the internet that can do embedding, that can take a piece of text and create a vector that captures semantic. I'm using one of the oldest, derived from BERT, and just to show that even these models that are pretty old in this landscape are still really good. Now these cells show you an important thing. I transformed all the sentences, the 30 original sentences inside vector, and I calculate the module of each vector, and I print the result, and all vector are module 1. And this is important because in linear algebra, if you want to calculate the distance between two vectors, if the vector are unary vector have modules 1, you can use the dot product, and the operation it's not involving square root or other complex operation. So all these neural network were trained and were created with this goal in mind, because having module 1 vector allows you to perform very efficient operation to calculate distance between vectors. Then you can use pandas data frame to show this inside the table. And so you see in the diagonal, all the value are 1 because the cosine between the vector and itself, the angle is 0 and the cosine is 1. And then you see going on, you have the first, second, third. These are the first 10 sentences, the vector of the sentences. So the sentences are grouped. The first 10 talk about tree, as a plant. As you can see, the distance between vector is 0.3. And if you go down with 2021, so you see the latest vector, the constant similarity is low, demonstrating that actually we have an high constant similarity. So the vector is nearest for all the vector that talk of a tree in the same context. So indeed, this is intuitively show you that the vector derived from this model takes the concept of a sentence and transform into a vector that contains some of the concept inside the sentence. Now I have an utility called plot embeddings that is containing in the sample. It's in the visualization utils. I've taken from an example of another site, and it's a simple function that using UMAP, and UMAP has a nice function that is this one in line 14, reducer fit. So I've taken all the embedding and I'm plotting inside 2D. So this reduce the vector into 2-dimensional, and it allows me to have a plot of like this, and this is interactive. And if I'm going to one of these points, I can look at the original text, and as you can see, all of this, my family tree, I discover relatives. So all this green are the vector about family tree, and blue are the vector of the tree as a plant, and the red are the vector about tree as a data structure. As you can see, all these are clustered in a space that is reduced from the original space, because the original space is more than 700 dimension. And the UMAP library allows you to create a 2-dimensional representation where the relative distance are keeping good. So this demonstrates that indeed the model I've used capture sentences concept, because as you can see, all the sentences that talk about tree in a specific context are clustered together. And this is very important because this demonstrate that we are really able to take pieces of text and get a numeric representation that capture the concept of this pieces of text. And as you can see and you can understand, a numerical representation is perfect in computers, because you can do a lot of operation like cosine similarity to just try to find the pieces of text that are similar between them in a very fast way. And thanks to vector database, we have really fast implementation written in tools that you can use even for free, because we have a lot of vector databases that are completely free. And this changed the way you are searching things. So we have a lot of this library that can compress the vector from nth dimensional space to a 2-dimensional space for representation. And I've added another one taken from OpenAI example, just to demonstrate that indeed this vector are clustered in regions that are near together. And this is a different representation taken from some OpenAI example. So I call OpenAI plot 2D, and all the vector are still clustered together. But as you can see inside this representation, you see that the red vector and blue vector are somewhat more near and less separated than the green vector. And it's something that you can see also in the top example, where the green vector are in a completely different space, and blue and red vector are most similar. And this is another example on how you can use an online service like OpenAI to create embedding for you. So you are not forced to use a local model like I've used before, the BERT model. So you don't need to have GPU to have it run fast. You can just use a service. And this example is using Azure OpenAI, and it's simply going to do the very same experiment. I'm taking the same 30 sentences and use OpenAI to transform into vector and verify how they are displayed in a 2-dimensional space. I'm using the old embedding called ADA, text embedding ADA 002, because this is a very, very old example I wrote almost maybe 10 years ago, as soon as this model went out. And the example is very simple. You have an OpenAI client that works perfectly with OpenAI Azure, because I'm using the Azure version of the OpenAI. I can use client embeddings create, passing the sentences in the model I want to use. So this is an old model, and OpenAI has new model that can work perfectly. And I'm do the plot embedding, and what I find interesting is if you look at the embedding, as you can see, even if you use the ADA model from OpenAI, so it's a complete different model from the BERT one, we have a very same result. So we have always green, all the green clustered together. These are all the sentences with green. Green is the sentences as a family tree, okay? And the blue and red are near together. So probably there is some similarity in how this model were training, but probably there is a way in which we use the three word in English language that bring to this conclusion. So this is really interesting because it shows that using different model created by different companies from different machine learning structures, we end with a similar results. So this is, in my opinion, a demonstration of the validity of this approach of training neural network to capture sentences concept into vectors. Now let's conclude this video with an interesting example. OpenAI released months ago new embedding models like the text embedding tree large that supersedes the ADA model. So first of all, let's try the model using the same client from OpenAI, and I'm gonna use the original OpenAI. So when I wrote this example, the Azure OpenAI still didn't support the text embedding. So as you can see, I'm using a different key because this is the key from directly OpenAI service, but okay. The result is similar. As you can see with this model, I have a couple of things that I get looking at the representation. The first one is that the red and the blue are more separated. So it seems to me that this model better separates concept, and the green, it's not so distant. So maybe this model, OpenAI claim it's superior, and it's the successor of ADI, so it should be superior. And it seems to me that it does a very good thing into separating and clustering things together. They seems to be more separated. Now, if we look at the dimension of the latest large model from OpenAI, the dimension is 3072 vector dimension. And this is a really huge vector. As you can understand, if we are using vector with more components, probably the neural network is able to capture more semantic of the words of the sentences. But conversely, we had from the other side, the negative part is the bigger is the vector, the more operation we need to do to perform cause and similarity, to perform Euclidean similarity. So we need more computational power to find similar vector because clearly you have more operation to do. So the one thing that is really interesting about this new model from OpenAI is that you can choose to reduce the dimension, maintaining most of the characteristics. In this other example, the really difference is that we are using dimension 512. So I'm asking to use the text embedding tree large, but I'm asking to have only 512 vector dimension. So I'm reducing a lot vector dimension, so I need less computational power to calculate cause and similarity. The problem is, does this reduction affect the performance of my vector? Yeah, the answer is clearly yes. But the model from OpenAI claims and tells you that you maintain a lot of these semantics even if you reduce the dimension of the vector. So it's up to you. You should try with your data if this is still good. In this example, the idea is I'm going to 512 dimension are still the sentences clustered together, and the answer is unsurprisingly yes. As you can see, we still have all these three sentences clustered together. So yes, this is a very trivial example. The sentences are short, but this is just to show you that indeed this model works. And even if you reduce the number of vector, still the model works. So you can use this kind of embeddings that allows you to reduce the number of vector to find the sweet spot between performance and how many searches can you do in your vector database and compare to the quality of the result. And always remember that you can use a ranker to re-rank solutions. So probably you need to investigate in using less and less dimension until you find your sweet spot. And what about using 128 dimension? Okay, in this trivial example, still we have this object clustered together. So as you can see, this model are surprisingly good. So if you maybe work with short questions, okay, short sentences where you have maybe question of the user to your system and you want to find similar question in a question database, yeah, you see in short sentences, even if you are using very short vector, the results are surprisingly good. Clearly, when you are going low and lower on dimension, like 32 dimension, yeah, you're looking at a result that is not correct. Okay, so there's clearly a limit of dimension where the model is not able to capture the concept of a sentences. So usually you need to have hundreds of dimensions. So you see at 128 is still good. It seems good, at least on this example, but with only 32 dimension, the results are clearly wrong because we see all the color are mixed together. So we see a two cluster of information, and it is nice because the green and red are not intermixing. So the red is the one in which I use the data structure and tree as a family tree, and they are still separated, but blue is got intermixed. But the idea is I can use this new model from OpenAI to lower the number of dimension from 3,000 to hundreds, and still maybe these are good for my scenario. So we are looking at a lot of advancement in this area in latest month. So we can expect in the next month to have more and more and more news about how you can get good embedding with low dimension, very efficient for your searches. I hope you like this video. I'm waiting you to the next one.